So in question number 12, same number of moles of an ideal gas is taken from state A to A1 and from state B to B1 as shown. Points A1 and B1 lies on two different isotherms. If Q1, delta U1, Q2 and delta U2 are the heat supplied and increase in internal energy in these two processes, A1 and B1 respectively, then we have to check the validity of given statements. Then we have to find out the correct option. So, as the temperature of the gas increases, then the isotherm will shift in this direction. So, I can say that the temperature of this isotherm is more than the temperature of this isotherm, or I can say that the temperature of point A1 is greater than the temperature of point B1. So, if I plot an isotherm passing through point B as well as an isotherm passing through point A, then I can say that the temperature of the gas at A is less than the temperature of the gas at B, and the temperature at A1 is greater than the temperature at B1. So if I see the process A to A1, let the temperature change in this process is delta T1, and if I see from B to B1, let the temperature change in this process is delta T2. So I can say that the initial temperature at A is low as B and is high at A1 as compared to B1. So I can say that delta T1 is definitely greater than delta T2. So the change in internal energy in case of delta U1 is greater than delta U2. Now, in order to find out the relationship between Q1 and Q2, if I calculate the work done in the process A to A1, then the work done, then the area on the PV graph is more as compared to from B to B1. So I can say that delta W1 in case of A to A1 is greater than delta W2 in case of B to B1. So if I add this, I can say that Q1 is greater than Q2. So option C is the correct answer. Let's move to question number 13. In question number 13, a person standing at a certain distance from a source S of sound receives sound wave in two ways. One directly from the source, that is in this fashion, and the other after reflection from a rigid boundary at point M, and the another is in this way. The maximum possible wavelength for which the person will receive maximum sound intensity. So if I calculate the path difference between these two waves, one is this and the another which is coming in this way, then the path difference delta x can be written as, this separation is 6, this is 8, then this separation is 10. So 10 into 2, 20 minus 12. So it comes out to be 8 meter. Now this path difference must be equal to m lambda for the constructive interference, and it is given that we have to calculate the maximum possible wavelength. So in order to get the maximum possible wavelength, the value of m should be equal to 1. So lambda max comes out to be 8 meter. So option C is the correct answer. Let's move to question number 14. Question number 14. Two non-conducting spheres centered at O and O' having uniform volume charge density plus rho naught and minus rho naught respectively are placed such that they partially overlap as shown. If 2 points P and Q are taken inside the overlap portion, then potential difference Vp minus Vq between P and Q is equal to, and the coordinates of point O are 0, 0 and coordinates of O' are 16, 12. So in case of a uniformly charged non-conducting sphere, the electric field at a distance r from the center is given as rho upon 3 epsilon naught into r vector. So if I calculate the electric field intensity in the overlap region because of these two spheres, then electric field comes out to be rho upon 3 epsilon naught into O' vector. Or I can write rho upon 3 epsilon naught into O' vector is equal to 16 I cap plus 12 j cap. Now the potential difference between point P and Q can be written as E dot into PQ vector. So if I substitute the data, the value of E vector is rho upon 3 epsilon naught into 16 I cap plus 12 j cap dot. If I write the PQ vector, then it comes out to be minus I cap minus 5j cap. So rho is rho naught given in the question. So if I write in this way, it can be written as rho naught. Now, on solving this, we will get 76 rho naught divided by 3 epsilon naught. So option A is the correct answer. So the correct answer for question number 14 is option A. Let's move to question number 15. In question number 15, consider a neutral conducting shell of radius r centered at O. A point charge plus Q is placed at a distance 2r from the O as shown. Potential at P point on the surface of shell as shown due to induced charge on the shell will be. Since it is a neutral conducting shell, the potential at the center of the shell due to induced charges will be 0. So the potential at the center of shell is only because of this charge Q. So I can write the potential at the center of shell is KQ by 2R, and it must be equal to the potential at the point P. So that is equal to the potential due to induced charges plus due to charge Q. So it can be written as KQ by R. So on solving, we get the potential due to induced charges, and it comes out to be minus KQ by 2R. So option C is the correct answer. So the correct answer for question number 15 is option C. Let's move to question number 16.